Okay, so we're going to do this integration, a definite integration, where the condition is between x equals to a and x equals to minus a. We need to show that the integration of that is equal to a, where a is greater or equal to 0. First thing to do is to let u equal to 1 plus e to the power of x. And then I find the u, the x, equal to, if I differentiate 1, I get 0. If I differentiate e to x, I get e to x times differential of x. If you differentiate x, you get 1 times 1. And I need to make the x the subject because I'm going to replace the x. So the x will be equal to, so I just put it over there. So it's going to be du over e to x. But I also know that we know that u is equal to 1 plus e to x. Therefore, e to x will be u minus 1. So I can replace the e to x with u minus 1 equal to the u over u minus 1. So I can take this and put it over there, and I can put this as u. So if I'm integrating now, but I need to change my x, the boundary condition as well. So I'm going to integrate 1 over, this is going to be u, and the x will be du over u minus 1. And the boundary condition for my x, I can do that because when x is equal to a, u will be equal to 1 plus a, and when x is equal to minus a, u will be equal to 1 plus e to the power minus a. Boundary condition here, I'll put u equals to 1 plus e to the power minus a, and here u equals to 1 plus e to the power of a. So that's my integration. But that integration requires partial fraction. So let's do the partial fraction here. The partial fraction will be 1 over u into bracket u minus 1, and that will be a over u plus b over u minus 1. If I cross multiply, I get 1 equal to a into bracket u minus 1 plus bu, making them the same denominator. So the denominator we cancel out, we just have the numerator. I multiply that by u minus 1, I times that by u minus 1. I multiply that by u, I times that by u. Have the same denominator and they cancel out. So I got numerator now. When u equal to 0, b will disappear, and I put 0 here, 1 equals to a minus a. Therefore, a equals minus 1. When u equal to 1, so 1 there, 0, a disappears, you get 1 equals to b. So I'm going to put that, all that back into there. Integral u equal to 1 plus e minus a, and u equal to 1 plus e to the power a, and the integral will be, I'll write the positive first, b is positive, so I'm going to write 1 over u minus 1 minus 1 over u du. So now this is easy to integrate. The boundary condition, obviously, if I integrate that, I get ln u minus 1 modulus minus ln u modulus. And my boundary conditions are those: 1 plus e to the power a, 1 plus e to the power minus a. I can substitute that into there and substitute that into that, and take away from substituting that into there and that into there for u. So I'm replacing u as those. And so we get, if I put that into there for u, that 1 will cancel the 1, so I get ln e to a minus, if I put that there, I get ln 1 plus e to a, and I want to take that away, so that'll be minus. Now I'm going to do this, so that'll be ln e to minus a, because if I put 1 there, 1 will cancel that one, and I'm going to get e to minus a minus ln 1 plus e to the power minus a. So this is a divide, that's a divide, and that's a divide. So I got 3 divides. So what I'm going to do now is to put that as a divide, so we get ln e to the power of a over 1 plus e to the power of a modulus minus, that's that minus there, that's another divide, so that's ln, this will be e to the power minus a over 1 plus e to the power minus a. Okay, because this is a minus, that means another divide. If I take the ln out, that's another divide, so fraction over fraction. And when you do fraction over fraction, you can switch it and turn into times. So I'm going to turn that into times. So I get ln e to a over 1 plus e to a over, this is this fraction now, e to minus a over 1 plus e to the power minus a. So those are the two fractions. That's a fraction of a fraction. And that will become ln e to the power of a over 1 plus e to the power of a times 1 plus e to the power minus a over 1 over e to the power of minus a. So that's that. Okay, so modulus. But what I need to do now is to get rid of this e to the power minus a. The way I can do that is to times the top here by e to the power of a, and also times that bottom by e to the power of a for this side. That cancels that, you still get the same thing. If I multiply it out, I should get ln e to the power of a over 1 plus e to the power of a times, e to the power of a times 1, that will be e to the power of a, e to the power of a times e to the power minus a, that will be e to the power of 0, because the same denominator, you add the power, minus a plus a is 0. Because it's 0, e to the power of 0 is 1, so that will be plus 1 over e to the power of a times e to the power of minus a, that will be 0, e to the power of 0, and that will be 1. That and that are the same, so that cancels that. And what do we get next? We get ln e to the power of a modulus, and so you bring the a to the other side, that will be a ln e. We know that ln e equal to 1, so therefore the integration will be equal to a, since ln e equals to 1. And you can see, since ln e equal to 1. So this is what we've done. We integrated that. We get the proof that that integral of that is equal to a, and that's what this is.